Okay, LeetCode 141, linked list cycle. So in this problem, you're given a linked list and you want to find out if it has a cycle or not. So in example one, we see that 3 goes to 2, which goes to 0, which goes to -4, but -4 takes us back to 2, right? And we want to find out if that's a thing, if there's a cycle that exists. Um, Same thing in example two, right? 1 goes to 2, but 2 goes back to 1. So there's a cycle. In example 3, we're just given a single node. Obviously, there can't be a cycle there. So basically, there are a couple ways to approach this problem, probably two ways. The first one you might be thinking of is, well, let's just use a hash set, right? We'll use a hash set of list node pointers. And whenever we go into a new node, right, we just put it in the set. But if it's already in that set, that means we visited in the past, and we're just going to return false immediately. Otherwise, we'll just return true. That works. That's a linear time solution, but it's also a linear space solution, right? Because you're using some extra space there. That's going to scale linearly with the size of your linked list. Um, we can do better though. The one thing we can do better is we can think of this problem. We can step back for a second and not think about this as like a linked list. So let's open up Paint. And basically, what we can think of it as, let's think of like a track. Let's think of a circular track, right? Now, obviously, a circular track can be a cycle, and I'm doing a terrible job of drawing it. And this is not a donut. Okay, so we have a circular track. Obviously, as I said a couple seconds ago, it's a cycle. And what if we have two cars? And I'll just like draw them as little blocks here. We'll have two cars, a green one and an orange one, right? And we'll just have them infinitely go around this loop, right? And the idea basically is like, what if we start these cars, and actually it doesn't even matter where we start. Let's say the green car gets to start here, right? If the both of these cars move at the same velocity, right? Let's say this car is going like 60 miles an hour, but this one's also going 60 miles an hour. This gap between them is always going to be the same no matter where they are like on this cycle, right? But what if we think of this a little differently? What if we give, let's say, this car, like what if we make this car go 60 miles an hour, right? So it goes at 60 miles an hour, but then this car goes at 30 miles an hour. And like, let's pretend the drivers, they don't know what they're racing on, right? They don't know that they're racing on a loop. They just don't know. So basically, what we do is we have this car going twice as fast as the other car. And what does that tell us? Well, if they're both going to be going at their respective velocities without changing them, eventually the car that's going 60 miles an hour is going to pass this orange car, right? So there's going to exist a time t such that the positions are the same for both of these cars because this faster car is passing that car, right? Now let's think of like another scenario where we don't have a cycle. So let's say we're just thinking about like, a straight road, and this road, goes off a cliff, right? And there's going to be like lava there. Okay, so let's see. We have two cars, right? Let me get my pen out. So we have a green car, and then we have an orange car, right? And if let's give the orange car the faster velocity this time. So if the orange car goes at, let's say, 60 miles an hour, and the green car goes at 30 miles an hour, it doesn't matter, right? Because eventually this orange car is just going to fall off the edge, right? We can think of that as a null pointer, right? So it falls off the edge and it's gone, right? There's no cycle. We know that. So we can instantly just return that like, okay, false, there's no cycle. So let's think of this now in terms of a linked list. I hope that analogy kind of made a little bit of sense because it's kind of weird to understand this method at first. So let's do that at first example where we have 3 going to 2. going to 0, going to -4. And then -4 happens to loop back, I think it was to 2. Yeah, it's to 2. So this happens right here, right? So let's say we're going to have a couple pointers. So let's say our slow pointer, right? We'll explicitly say it's slow, is going to start at the head, right? And then let's just start our pointer that goes twice as fast, one step ahead, right? Okay, so let's do this. So now though, let's set our velocity. So let's say that the slow pointer only gets to move one ahead every single time, right? But our fast pointer is going to get to move twice as fast. So it's going to, instead of moving only by 1, it's going to move by 2, right? So let's just run through this example. So let's do this. So in the first iteration, this pointer moves here, and this pointer gets to move all the way here. In the second iteration, this pointer gets to move here, and then this pointer gets to move once, and then twice, and then boom, they just caught the green pointer just caught up to the orange pointer because it was getting ready to lap it. And that means we have found out that we are in a cycle, right? Now, if we were in a cycle, so let's say, for example, we remove this connection right here, we delete it, and we make a connection to like a null pointer, right? Representing that cliff we talked about. So this time though, if we set our cars back to their initial positions and their respective velocities, so iteration 1, this gets to move by 1, this gets to move by 2, right? This, oops, sorry. Again, this gets to move by 1, but then when this tries to move by 2, it gets to go to null land, right? It gets to go to null. So we know that our fast car just fell off the cliff. So we're not in a cycle, right? It's just a straight road. So let's try to put this in a code, right? So we're given a couple examples, and I always like to go for the base case first. So we know that if there's no head, right? So if we're not given a node, or if there's no next, right? If that head isn't connected to anything, it's just a lone node, then we can immediately return false, right? Because a single node or a non-existent node cannot have a cycle in it. Otherwise, we're going to initiate our pointers. We're going to have a list node pointer. We'll call it slow, and we'll make it equal to the head. We'll have a list node pointer. We'll call this one fast, right? And we're going to be setting their position. So we'll start this one off at head next. Cool. And then we're just going to say, let me first fix my spelling here. It's a lowercase I. And so we say, okay, well, while fast, right? While fast isn't null, so while we haven't fallen off the cliff yet, we're going to say if fast has ever caught up to slow, we're going to return true, right? We found out that we have a cycle. Okay. Otherwise, there's another case we need to look at. If there's no ability for fast to go to a next node, right? It means that we found like an edge of a cliff. So we're going to return false here, right? Because our fast pointer just ran into like the edge of a cliff and it's about to fall off. So we're going to say, okay, no cycle, right? Otherwise, slow is just going to be equal to slow next. So slow gets to move over by 1. And then fast gets to move over by 2, as we talked about in our little diagrams. So we do this. And then otherwise, if we go through all of this and we don't return anything, we just return false, just in case. So let's see if it runs. It runs. Cool. Let's do the example test cases. They all work. Let's submit. There we go. 45% fast. Let's try again. There we go. 99% fast. It fluctuates. If I do it again, it'll be slower. That's just how LeetCode is. Runtime. This is oven, right? Because we have those 2 pointers, and if we don't have a cycle, all that happens is that we run through and we fall off the edge of the cliff. We only go through it once. Space complexity. Again, this is O of 1 because no matter how big our linked list is, right? It could be a length of like 10,000. We're only going to ever create memory for these 2 pointers right here, and that's it. So I hope this was somewhat intuitive. It's kind of a tricky solution to come up with on the spot. I don't think you should be expected to, but once you know it and understand it, I kind of feel like you know it and you've got it in the bag. So yeah, I hope this helped.